Guys, today we're going to start graphing sine and cosine functions. Today we're going to start very small and then we're going to add on little by little until we can graph the entire thing from top to bottom. So I'd like to focus on amplitude and period today. Before we can focus on amplitude and period, we first need to look at the parent functions for sine and cosine. So those parent functions are going to have some critical points. The first critical point that I'd like to highlight inside of a sine function are the x-intercepts. They're at the whole pi's, negative 2 pi, negative pi, 0, 0, pi, and 2 pi. Notice that we are dealing in radian modes. You're going to see radians this whole time. Okay, again, those x-intercepts are in what we call whole pi's. Now let's take a look at my maximums. My two maximums in this picture are going to be negative 3 pi over 2 and pi over 2. In addition, we're going to have some minimums. So in this picture, I have negative pi over 2 and 3 pi over 2. Notice that I'm saying in this picture, that's because these curves go on forever and ever and ever. So I really could write them forever as well. So now let's talk about domain. Domain is negative infinity to positive infinity, which also can be called all real numbers. Your domain, or your range, your y values, they are going to be from negative 1 to 1. We're going to give that a special name in a second. So now let's talk about the critical values in a cosine function, starting with our x-intercepts. These are going to be on the half pi's. So we're going to be on negative 3 pi over 2, negative pi over 2, pi over 2, and positive 3 pi over 2. Again, those are the half pi's. Then let's talk about our maximums. Our maximums are going to be at negative 2 pi, 0, 1. That 0, 1 is going to be a real big point. In cosine, I'm going to reference it quite a bit, as well as 2 pi. Then my minimums are at negative pi and pi. Domain is still going to be negative infinity to positive infinity, and range is also still negative 1 to positive 1. So take a look at those side by side. They're actually really similar. One of them, if you look at the units in the graphs, that's the reason why they look different. Okay, so the two vocabulary words that I want us to, focus on today, but before we can focus on them, we need to know what the basic function looks like. So for sine, I'm going to have f of x is equal to a times sine bx plus c plus d. Sine is going to look exactly the same way. And what's going to be nice is that A, B, C, and D are going to do the same thing. The difference is where they start. So today I'd like to consider A and B, okay? More specifically, amplitude and period. So my amplitude algebraically is the absolute value of A. That's nice, right? Amplitude A. Graphically, it's going to be half of the height of your curve, which I know that can be kind of confusing. So another way of thinking about it is it's the curve height from the x-intercept to as high as you can go, okay? So it also could be the x-intercept as low as you can go, okay? That's going to be amplitude. Your period, so to find the period algebraically, what we're going to do is take our 2 pi, which is a full period normally, or a full rotation, and we're going to divide it by b, the absolute value of b to be more specific. Graphically, it's going to be one full curve. So what you're going to hear me say is we're going to have a starting point and an ending point. So that starting point and that ending point is going to be the period, okay? So when you start here, we're going to start all of our sines at 0, 0. That period, again, or the amplitude, is the height from the maximum to the x-axis or the minimum to the x-axis. So for my period, I'm going to start at 0, 0 and go full curve to 0, 0 again. Notice that I have to pass through 0, 0 one more time, and it's in the middle. Now this one's going to show you the full curve so you can kind of compare it to sine. But really what you need to do is start your full curve at that 0, 1 and then watch it repeat. Okay? You're going to see several of these, and we're going to practice them for a couple days, and you may find a technique that works better for you. That's okay. So now let's take a look at a couple examples. The first example we have is 2 sine 4 theta. Okay, so for my amplitude, that comes from A, so 2. So what I'm going to do in a second is I'm going to highlight what that amplitude is. To find my period, I'm going to do 2 pi over the 4. absolute value 4 is 4. 2 over 4 simplifies to pi over 2. So now I'm going to highlight the amplitude here. So I can't go higher or lower than those blue lines. Okay? Since it's sine, I'm going to start at 0, 0. Okay? So that's my first point. Then I also know that I'm going to have an ending point at pi over 2. That's also going to be an x-intercept. Notice that I put one at pi over 4. That's because that's in the middle. Then I'm going to take that one curve and I'm going to make it a pattern. So I know that I'm going to have x-intercepts basically at every single quarter pi. So I am going to fill those in and just go up and down and up and down and up and down. Remember, do not cross over those blue lines. Let's try that again. Example 2, cosine 4 theta. This time, I don't have anything in the A spot, so that means my amplitude is 1. Here we go. Don't go above or below that highlighted line. Ooh, one of those lines is wrong. That's at a -2. We should probably fix that. Make sure you fix it in your paper. For the period, we're going to have 2 pi over 4. Simplified, you get pi over 2. So for cosine, we're going to start at 0, 1. Okay? Then I know that it's going to complete the curve at pi over 2. So at pi over 2, I'm also going to do a point at that blue line, okay? Then I know in the middle, I'm actually going to hit the blue line below. So cosine's a little bit different. So with sines, the way that I think through them is I'm thinking through the x-intercepts. While with cosines, I'm thinking through max and mins. That's what works for me. It might not work for you. So if you find another way to think this through, that's okay. So again, for sines, I do x-intercepts. For cosines, I do max and mins. Okay? Let's see that a couple more times. Let's go back through a sine problem. So for this problem, my amplitude is 2. So let's highlight the 2's above and below. So we're not going to go past those 2 lines. This one's going to be a little fun. So this time for my period, I have 2 pi over 1/3. Keep, change, flip. You've heard that a lot. So I'm going to start my sine function at 0, 0, and I know it's going to hit 0, 0 again at 6 pi. The middle is 3 pi. Then I'm going to go up and down, and I know I'll hit it again at 9 pi. So this is going, I'm going to hit an x-axis at every 3 pi. Okay, let's try again with cosine. Amplitude's 2. You see that a lot. That 2 comes up quite often. It's just a coincidence, though, that's happening here. You could have other things besides 2 and 1. Okay, now for my period. I'm going to take 2 pi over 3. This one's going to be complicated because the fraction's a little bit wonky. Also notice that my cosine amplitude is 2. So instead of starting at 0, 1, I'm going to start at 0, 2. Then I know I'm going to hit 0, 2 again at 2 pi over 3, which is between pi over 2 and 3 pi over 4, and then about in the middle. So if you're doing some guesstimation for this first one, that's okay. Again, with cosines, I like to do max and mins. You might need to watch these examples again, and don't worry, you're going to hear these words and this procedure one more time tomorrow whenever I add 2 more features. This is all I want you to practice today, finding amplitude and period. Number 4 is challenging because of that wonky fraction, but I know you can do it. Happy math!